In this video, we will discuss another method for creating a working algorithm package based on a set of draft algorithms. This method is as follows. Having a large amount of statistical data, we divide it into fragments and search for algorithms in these fragments. Then we check how these algorithms work in all statistical data and select only those that match the specified parameters. Let's take an example of this process. The diagram shows a complete array of objects consisting of 1,700 elements in blue. We will select chunks and look for patterns in them. For clarity, let's look at two fragments. First, we will select a fragment that starts with an element with ID 400 and contains 101 objects. We will find the algorithms in this snippet and check how they work in all 1,700 objects. Then we will select only those algorithms that meet the specified requirements. 2. We will do the same with the second fragment, but select the fragment that starts with ID 450 and contains 151 objects. Let's put this into practice. We have statistics that show a total of 1,700 objects. Of these, 692 are positive and 1,008 are negative. Each object contains 503 parameters. To search for algorithms, we will take data starting from the 400th object and select 101 objects. When searching for algorithms, we will use criteria that will allow us to find as many algorithms as possible. As we can see, we have 3,907 algorithms. Let's see what we can do with them. First of all, we can plot the performance of algorithms in the area that we considered. This will allow us to see how the algorithms will perform in real-world conditions. Second, we can check how the algorithms work with the full set of statistics. To do this, we will create work schedules based on the entire database. In this case, we will observe graphs where the algorithm's operation will be highlighted in red, in the statistical data where we searched for it. In blue, the algorithm works on other statistical data. The green line on the graph represents a linear regression. As you can see, the graphs differ from each other, but we can only select graphs that meet certain criteria. Let's do it. First, we will select graphs with a predominance of positive features over negative ones. There were 1,320 such algorithms. Let's look at these graphs. Obviously, many of them are not very attractive. Now let's sort the graphs by linear correlation, setting its value to 0.95. As we can see, there are only 111 algorithms left, and the remaining graphs show the best results. However, some algorithms can only be applied to a limited number of objects. Let's set a criterion. The number of objects must exceed 60. In this case, only 35 out of 3,185 algorithms will remain. Let's take a look at the resulting graphs. As we can see, only the graphs that show good results are left as a result of sorting. Let's make sure that our calculations are correct. To do this, let's check how the algorithm number 20 works. Let's save the found algorithms and transfer the file to MetaTrader. In the code, we will set only the 20th algorithm to work and run the program. As we can see, the results are exactly the same. 47 positive objects, 41 negative ones. The graphs are also absolutely identical. Let's look at another fragment containing 151 objects and starting with 450 ID. As we can see, this fragment contains 669 algorithms. Let's create graphs and sort them by the same parameters as in the previous chunk. As we can see, we have only 4 algorithms left. Let's take a look at their charts. The charts look quite satisfactory. So, let's generalize. We can select and process individual chunks from the general set of objects and get algorithms that meet certain criteria, creating a draft version based on them. We can then use various methods to process this draft set, as shown in other videos. For example, we can combine algorithms based on certain criteria or calculate a non-linear regression based on the natural logarithm. So in this video, we've covered another method of working with algorithms.